order. The normal order of events. Thomas, keep an eye on the folks in the waiting room, please.
I'm on it.
First thing we'll start off with is robot news. Any robot news this evening?
Well, in AI, you have a new version of ChatGPT 5.1, supposed to be so much faster, smarter, blah, 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 blah. I haven't noticed much.
There's a humanoid summit in Mountain View. Let me share the screen. And I'll put the link in the chat. I suspect Tobar Life will be there with the some of the Unitree robots.
The date on that,
also, pardon?
Also, there's a robot block party on Saturday in Mountain View.
Where is the robot block party this year, Dee Dee?
I think a circuit launch. You're right. We've had a circuit launch robot block parties before, but they used to be in Oakland. But now there's a Mountain View, so it's a shorter commute for those of us in the South Bay. And they have Brazilian barbecue.
Somebody mentioned something about Brazilian barbecue. Can you find a link somewhere and put it in the chat?
Okay, I'll look for it.
Actually, in addition to the chat, can you put it on the mailing list?
Okay.
That would be really helpful. Thanks.
Everybody's familiar with the mailing list, I guess. hbrobotics.org, and there's a Google group that you can join. It's really an excellent group. Let's see here.
Meta output, Meta open sourced apparently a translation system, a translation model trained on 135 different languages. So that ought to eventually help with voice control of robots one way or the other.
Can you find a link and put it in the chat when you?
Yeah.
And maybe put it on the mailing list also. There's a Ross by the Bay on December the 3rd. I'll put a link in the chat for that, and I'll post to the mailing list also.
You doing news?
Yes.
Yeah. We just got wind of this new robot, Mind On. It's this humanoid that's it's using the Unitree hardware, but it's a software company, and they're this whole idea of like happened with the computer revolution, home computer revolution. The software companies flourished, making many programs to run on the robot, and now this is could be a flashpoint. If you want me to share, I have the video.
Let me enable screen sharing.
Looks like it's gone. Let's try sound, video. It's just music. I watched this and a review of it, and they're saying there's a bunch of, it's probably reinforced learning but also sort of kind of pre-staged sort of to some degree, but it is autonomous. but it can handle such incredible positions that are kind of difficult to, very, very difficult in robotics. These like kneeling on a bed and crouching, picking up something off the floor. You'll see in a second here. And but this is a Unitree robot, and MindOn is a company writing code and training and all that stuff. This like particular
that looks like their taller robot. I think it's the H1 or something. It's not a G1.
I think this is the G, isn't this the yeah, maybe I forget which model it is. You might be right. It's definitely not the short one, right?
The G1 is the short one.
Right, it's not the G1, it's the H1. But yeah, you can see how it they were in the review, the guy was reviewing it and said this, part of it is definitely going fully autonomous or fully using its learned behavior, but other parts might be what they call blind or kind of replay or something, what they were calling it. But anyway, it is quite an interesting development. MindOn company. Oh, I'm sorry, I quit too early. There was one more. This last scene here. You saw like he's throwing a frisbee, and then this post scene here picking up. Now this one, people were like, we think that maybe it was teleoperated, but I mean, it's just conjecture. Because the only reason they said that is because it doesn't show on the screen they had text saying this is completely autonomous and not teleoperated, and they left that out on this screen. But I like how he just, anyway, but it does say everywhere else that it is no speed up, no teleoperation. So,
Well, that R1 coming down the pike looks interesting. They throw a $5,000 number out there, but try and get one for that price. And also, it doesn't have the LiDAR and so forth that the G1 does. And I think the one you were showing is the H1. That's like, $100,000 worth of robot.
Yeah, it's not cheap, but it's pretty amazing that they've done with it.
It's very amazing. Yeah. Hold on to your hat. What else in industry news this evening? Anything else?
There's XPeng's iron robot. XPeng from China. That's the one that looks like a female, and everybody says, "Oh, there's a person inside." I got a video queued up if you'd like.
Go ahead.
Quietly becomes ordinary life. When it walked on stage, the posture and balance looked familiar in a way that caught people off guard. That lifelike motion is not a trick. Iron is built around a spine-like core with bionic muscle groups, layered synthetic skin, and careful human proportions that make presence and interaction feel natural. The hands are the highlight. Each hand carries 22 degrees of freedom, powered by tiny harmonic joints that still fit inside a human-sized palm. Across the body, iron totals 82 degrees of freedom, which is why it rotates, gestures, and shifts, weight the way people do. The intelligence stack is part of XPeng's physical AI program. Vision language task and vision language action models coordinate what iron sees and hears with how each joint moves, and an in-house compute platform delivers about 2,250 TOPS to fuse sensing, planning, and action in real time.
Hey, Thomas, put the link in the chat, okay?
Robot is meant.
Yeah. You want to see more? Or we're done.
We're done. Yeah, put the link in the chat. Folks that want to check it out can check it out. There's also the 1X. The 1X computer's been getting some press. I think that one's human operated. And so it's like, you have to not mind somebody else being in the house, but it's an interesting concept to do the teleoperation and so forth until it gets automated. That's 1X and our friend from Kind Robotics, their company got acquired by those guys. So that's very exciting. What else this evening in industry news? Anything else somebody wants to share?
This is Jim Boteri. I've got some interesting wires, if possible, to share in a little bit of a presentation, but I don't know if this is a good time to do that later.
Are you local there?
Yes. Yeah.
Are you the guy we talked to on the email that has the component?
Yes. Yeah.
All right, let's do this thing. Go ahead.
Okay. Let me just. What's the second?
And you are
I'm Jim Boteri.
Jim Vortier. Okay, ladies and gentlemen, Jim Vortier. If it was next week, you wouldn't have made it.
Are you signed on? I am signed in, so let me quickly share my screen, and I'll just share a couple slides, and then I'll show you some parts in person here. Okay. Sorry about the delay. Let me know if you guys can see that at all.
We can see that.
Okay, so real quickly, so Maiden, we're a Taiwanese company, but been around for about 40 years. Basically, the company got started building the little tiny conductor that goes between loudspeaker voice coils and the connectors. And it turns out that's a really challenging piece of wire to build. There's a lot of very interesting motion that goes on and lots of failures if you don't do it right. Essentially, the building blocks is tinsel wire wrapped around a core. The metal can be, typical kinds of copper metals and alloys, can also have coatings and that kind of thing. But the core is interesting because it can either be stretchable or incredibly strong using Kevlar and that kind of thing. You take those kind of fundamental elements and then you braid them in really interesting ways. And that gives it some pretty amazing properties, lots and lots of different variations on the theme, which end up being much more flexible and much more durable for essentially, depending on the configuration, millions of cycles. There's a lot of strange motion that starts to happen instead of just bending, especially in robot applications, as everyone knows. And Maiden has developed a lot of very interesting test equipment to validate whether, in fact, motions such as these actually can survive. So a lot of home build equipment to kind of find durability. Lots of customers. We're working a lot of research universities in robotics space because of their interesting properties. And we think they're really, really appropriate for especially humanoid robotics. So I want to just share a little bit. This is an example of one of the conductors that we make. This is the 4-conductor cable, and I'll show you a little piece. In fact, if you guys can, I'll pass this around the room, and then I'll show you closer on the camera later. It will stretch about 40% of its length. And what's great compared to other more elastomeric-based conductors is that the resistance doesn't change.
Take like 2 minutes
as you stretch it, which I think is pretty unique. So the wires can be built in many different sizes. These are very, very fine. They can be sewn through a sewing machine. They can be ironed on, more on the e-textile side of things. But they can also be built to handle up to 40, 50 amps in some cases. So this is a little mock-up that I've built. It basically, your typical lamp, for example, or any arm that moves, you have to have a very generous bending radius, in order to accommodate the motion. This is a little mock-up that I'll just pass around, and maybe I'll show it. Is the camera, I don't know if you can see this or not, but basically the wire, rather than it needing to have a generous service loop, the wire simply stretches around the corner. So it allows you to really control exactly the motion. And you can see as it bends, the LED is not changing brightness, the resistance stays solid. And then this is when you start thinking about these wires, because of their durability and their flexibility, to not only be electrical conductors, but also to do mechanical work. And there's versions of this, as I mentioned, depending on the core material, that are Kevlar and extremely strong and not stretchable. And so what we've done is built a little mock-up finger that has the stretchable conductors on one side and the non-stretchable conductors on the other that acts like tendons. And so you can start doing the mechanical functions as well as the electrical functions. I'll turn this on. So this LED is being powered by those tendons that are doing that work. Oh, great. Awesome. Yeah, so this is an example of the tendon on one side, stretchable on the other side. So probably a little difficult for you guys to see online, but I can certainly pass stuff around here. And what we're trying to do is, we've been around for a while, but very few people know that this exists. And so we're trying to connect with communities like yours to just make sure that people know that it's around.
Is this the last slide, Jim?
Yes, it is. Yeah, I'll just
Go
stop
back,
there.
Go back to live. I want to see the live finger. You had it in action there.
Okay, to the live. Yeah, hang on.
Yeah, just stop
okay.
screen sharing.
Sharing. Right. Okay, so let me just show this up close. Yeah, maybe you can do it. Yeah, perfect. Okay, so this is the one example.
So I'm going back to the other one. Sorry. Okay, there you go, Thomas. You got it.
I don't know. Okay, here you can look a little bit. So this is the one that stretches around the corner. So it's just basically stretching the conductor. And if you can see in my camera, for those who look on you, and then the finger. So this is the finger. So this is the.
Hang on a second. Hang on a second. That's not the highlighted. Hang on a second. Bear with me.
Okay, can you see?
I'm trying to. Okay. This is
you
the
got it?
spotlight.
I found it. You got it. Never mind.
Okay, there you are. Do we want to use Kyung's camera? We want to use Kyung's.
All right, where am I looking now? Oh, here we go.
There you are. Okay.
Okay. All right. So this one, I'll try to keep it in focus, but so stretchable conductors on the backside. This is one of the 4 conductor cables. Non-stretchable tendon on the other side. I don't know if you can see that. And so by simply pulling on the tendon, we're able to actually move the finger, right? So normally you never want to use electrical conductor to do this kind of mechanical work, but because it's so durable and can be bent in such a tight bending radius and packaged in such a tight space, now all of a sudden that's possible. So, humanoid fingers in particular is sort of the ultimate application for this technology. And happy to sort of do some demos here in person more. We have a bunch of different versions. They're very interesting. Maybe I'll leave it there unless there's some questions.
Sure. Post to our mailing list too, Jim.
Hey, Jim, what is
I have
the
a question.
voltage and
Given that we're mostly hobbyists,
Yeah.
have somebody get a hold of this? Do you need to sign $1 million contract, or can it be?
No. So what we're trying to do is put small quantities of stuff that we have in production in people's hands to play with it.
How?
So I've got, I have samples here that anyone who's interested can have a sample and take it home and play. My email is on there. So just give me a email message and we'll see what we can do.
So somebody would order direct from you?
Yes. Yeah, absolutely. Here, based in Taiwan. Ian is from the mothership. He's one of the bosses over there. So he has a little more depth in terms of some of the technical details if anyone's interested in doing it.
Is this information on your website as well?
Most of it is.
Yeah, depends on the model. Yeah, some of this is pretty new. Yeah.
So if you could post that to our mailing list, that would be helpful.
Yes, absolutely.
And it's pretty easy to terminate.
It is the 4-conductor. So the 4 conductors actually the conductors are magnet wire variants. and they have an enamel, so you just burn it off like you would magnet wire with soldering iron, and it's easy. All of these are just 3D printed mock-ups that I built myself, and have done all the soldering myself using that 4-conductor cable. So yeah, easy to prototype with. As you get smaller and smaller, some of the wires that are so fine that they can be sewn with a sewing machine. Depends on how they're configured. Sometimes it requires some more complicated process, but generally it's straightforward.
Can you use these conductors to apply force? Like if I want to pull on something. Let's say I wanted to make a tendon and an electrical conductor out of the same run of wire, okay? Can it do that?
Yes, you can.
Yeah, it's strong in tension. It's not strong in compression, obviously, but if you want to pull something, this one in particular is a fine wire. I don't know if you can see, it's not going to focus, I don't think, but very fine. It has a Kevlar core, and I'll pass it around, but it's extremely rigid in tension, and I think it's good. The fail point on that particular one, I believe, is several kilograms, if I'm not mistaken.
That's interesting.
So,
Yeah.
Kevlar is not too bad, but you often, like one of the better materials is the high density polyethylene. I think it's polyethylene or polypropylene, one of those two, right? Like Dyneema style.
Mm-hmm.
Yeah. So have you guys used that as a core?
We have Dyneema, we have LCP, and then we have Aramid. So it really depends on what you're looking for, but we do have all those material. Yeah.
Okay.
Make a post to the mailing list, Jim. Okay.
Sounds great. We'll do that.
Very fine. Thank you very much. Is there any more industry news this evening? All right, let's move on into club news. Is there any club? Hey, this would be a time to do the elections, wouldn't it, Dan?
Yeah, I have a little bit of announcement. So where do I look? On the front, okay. So for anybody new, I'm Dan Tuckler. I am the outgoing treasurer and secretary. We have badges. We have badges for the first time in a long time. So years ago, pre-pandemic, when we had 100 people showing up in a space at Google, you had to have a badge. It was a big deal. Since then, it's been a lot less important. Oh, wow, it's daytime. But a lot of people collect these, including me, and want to have a badge for each year that they've been a member of the club. And I have somewhere at home a string of like 10 of these things. So thank you to the people that have become members for 2025. I'll be contacting you and we'll be mailing out badges for 2025. Going forward for 2026 will be a new treasurer and secretary. And so they'll determine what the approach will be for badges. But I do want to make a plug right now for joining the club. Okay. It's $10 per family per year. It hasn't gone up since at least 10 years ago. It supports the club, its community. It keeps us legal. We need to have a verified list of members when we go talk to banks and things like that. So I encourage you, sign up now. There's a link on the homepage that will get you to the membership and dues. Please put your name and email in the message on PayPal, because PayPal tends to strip out any useful information. It's kind of a pain, but that's where it is. So please sign up now for 2026. Let's start the year off with a nice, strong membership list. Okay, over to you, Camp, for elections.
I am putting that membership link in the chat. Bear with me here.
Camp, when the meeting is over and people want to get all these things that are in the chat, where do they find it?
When we post the video, the chat will be in the comments.
Okay.
Hang on a second here. Get involved. That's where it is. Become a membership dues page.
Put it on the mailing list earlier today.
And it is in the chat. All right, let's do this election. Let me get up the list. That'll be the best way to do it. Uh-huh.
You're only supposed to vote if you're a paid up member, so we'll go on the trust system here. Hopefully there'll be no investigations. No lawsuits.
The nominations are still open, okay? Bear with me. Let's see here. Okay, elections. HBRC elections.
Yeah, I just
Okay, this
put the
will
linked
work.
officers in the chat.
Okay. Is this the? Let's see. Okay, is that the page? Let's see here. Okay, that's the current officers. All right. So what we've got is
Screen share will be better.
What's the question?
Can you share your screen?
Okay, I'm working off of an email. Yes, I'll share my screen. All right. So what we're looking for are president, treasurer, secretary, program chair, sergeant at arms, and webmaster. I'm nominating Thomas Messerschmidt for the treasurer secretary. This email's let's do this.
Screen is a little bit small, so.
What's the question?
Why are you making that?
Text is too small.
Okay, I'll make it larger. Thomas, spell your last name for me.
I'll put it in the text.
Okay.
MESSERSCHMIDT. There's a D before the T. There you go. It's a long way of spelling Smith.
Yep. Year. Hang on a second here. I need to find some way to enlarge this. Okay. Nominees. President Camp Peavy, Treasurer Secretary Thomas Messerschmidt, Program Chair Nathan Lewis, Sergeant at Arms Kyung Cho, and Webmaster Stephen Williams. I'm going to make a motion that and only people who are members can vote here, that we vote in all these nominees for the office. All in favor, say aye. Aye.
Aye. Aye.
Those who oppose say nay. The ayes have it. Their officers for next year are myself, Thomas, Nathan, Kyung, and Stephen. Thank you very much. Yay. We promise we promise an entertaining year, if nothing else. I can guarantee you that it's going to be entertaining. Okay.
That election was a real nail biter this time.
Well,
one detail is the effective date for this is January 1st. So we can use between now and January 1st to do the transition.
Yes. Yes. Okay. So is there any more club news? We'll have a sometimes annual holiday junk. We'll continue the sometimes annual holiday junk exchange on December the 17th. I hopefully we can do that at Maker Nexus. So stay tuned. Is there any other club news this evening?
I have 3 books here that were donated by Ralph Hicks. If anybody wants these, Ross by example, Jungle Introduction to Ross, and Kicking Bot. So,
That sounds
Kicking
like
bot, huh?
yeah. If anybody wants to pick these up,
Kicking Bots by Grant Imahara. Yeah.
yeah, my bot got run over by a reindeer. So,
Kicking Bots says Guide to Building Combat Robots. Combat robots, and there's a combat robot on the cover with a thing that would slice another robot in half. So if you're into that,
if you're tired of Camp's display, a good combat robot could take care of that.
They cleaned the floor with all them Roombas and stuff.
Any more club news this evening? Let's move on to I need help with. Is there a specific I need help with? Did somebody discover something, got help with something this week, something like that?
I have a quick question for the those of you who are Nav2 experts. I'm working on a Visual Slam project, and I've managed to get past everything except I don't really have a whole lot of experience with Nav2. So if you know, this is such a stupid question, it seems like. Because it's like I should have done this a long time ago, but I haven't. If you know how to bring like just the default Nav2 stack that allows you to receive a published goal and navigate the robot to it. I'm using Foxglove, and I'm clicking on the like you do in RViz, you click on the point you want to be the goal, and I can even see the messages getting into the the Nav2 stack, but the robot's not moving, and it's having some problems reading like various topics. I'm looking at like remapping things, but it's possible that I'm just doing something really
Foxglove
stupid.
is used for visualization, right?
What?
The Foxglove is used for visualization, right?
Yeah, but they have like they have an RViz like interface.
Do you have a physical robot?
Hmm?
Are you using your physical robot?
Yeah, this is a physical robot.
Okay.
Like when you're running Slam Toolbox, or when you're doing like just the ROS 2 version of, click on a point in RViz and the robot goes to the goal. What's running under that?
So, well, Command Vel's driving it, obviously.
Yeah.
What's driving Command Vel? There's
got to be like a planner or something.
Well, it's one of the controllers, local path planner, global path planner, or
okay.
Phrase up your. Go ahead.
Is that encapsulated in a single launch file, or are there multiple nodes that I have to run here?
When I do two things. I run the localization launch file and then Nav2.
Okay.
Yeah,
You have
unless
to be careful
unless somebody else wants to
with
take
the
this shortly.
you have to be careful with the command that you multiplex that correctly between your teleop and your messages that come
Right.
basically from
So there's a
from your
separate,
stack.
there's a separate localization. Actually, you know what? I've already got a localization stack running. This is a VSlam. So it's a visual slam. And the robot is already able to localize.
In nav2 bring up, it's a localization file that launches the map server, the AMCL, and then life cycle. Then the nav2 gets launched separately after that.
Okay, so you would launch the localization.
If you look at nav2, if you look at nav2 bring up, if you bring up nav2 bring up, in nav2 bring up, there's a localization launch file that loads in the map server, AMCL, and life cycle.
Okay. So ROS2.
Put that in an email and on the mailing list, and let's talk about it. And come to the Ross discussion group on Tuesday night.
Right. I always get the messages for because I'm on the digest mode. I always get it like on Wednesday morning.
It's not hard. It's not hard, Stephen. We meet at 7 p.m.
I'm horrible at calendars.
It's not hard. Okay. What else I need help with this evening? Anything else? All right, we need to move along. Show and tell. We got anything for show and tell this evening?
Yes, I have one.
Go for it, Jim.
Here's a quick video of Big Orange doing with my latest AI integration, a sort of it's called LangGraph, and I'm using Chat GPT 4.1 and pulling in tools and allowing the AI to control the robot from a prompt, essentially.
Are you trying to share your screen? There it comes.
There it is. So here it's
Orange.
just 2 minutes.
Hey, Orange. Move to the desk, take a picture, then move to the hall, take another picture, then come back and tell me what you're doing as you go.
Here's my plan. Desk and take a picture, then move to the hall for another picture, return to the starting position, and narrate each step as I go. Moving to the desk now. I've arrived at the desk. Now, I'm going to take a picture here. Desk photo is taken. Next, I'll move to the hall for another picture.
Did you use Ross or you Slam Tech?
No, this is all Slam Tech and plus my Python.
I've arrived at the hall. Now I'll take a picture here. Hall photo is taken. Now I'm going to return to my starting point.
Is the AI keeping track of the tasks as it's performing them?
Yeah, so this whole thing is all being driven by AI. There's no code, no hard code for any of it or any of the things it's saying.
I'm back at my starting point. I went to the desk in hall, took pictures at each spot.
That's pretty cool.
Mission complete.
Yeah, so this is using a thing called LangGraph, and and it automatically stopped my sharing.
Hi.
That's
Actually, it's open. It's yeah. I haven't used it yet. It's like but that right there. There you go. Thank you.
Yeah.
Thank
So that is LangGraph is this. It's a system combined with LangChain, which is a whole API kind of convention system on top of AI chatbots and agent architectures. So, I'm adding all of the things that Orange can do, like 50 different operations or whatever, into as tools for the LangGraph system and the chat bot to be able to use. And so pretty soon it's this, now you can see it's combining things. I've got it to, evaluate at each step if you want it to. You could just say, go to these 3 places, take pictures, and don't tell me until you're done, and it will do that. So it knows how to go from these different nodes between, say, a thinking, essentially, when the chat, sending the information to the chatbot, then executing a tool that the chatbot asks it to, then going to my speech output when it wants to say something, and then looping back and thinking again. And also, if an event happens, like if it has an error, or stops for some reason, and then that will also go back to the chatbot, and it will say, "Oh, I couldn't go. There was such and such happened." And as long as your functions return something in English that happened, like there
That's
was
awesome.
something in the
That's
way.
awesome. Thank you very much. Thank you very much. Who else has a show and tell this evening? Thank you very much, Jim. That's awesome. Big orange.
Thanks. I'll turn off.
Who else has a show and tell this evening? I actually was able to do a circumnavigation. It has the last map I made is crap. I did actually map the house here, and as you can see, it does drive and localize. I'm not going to attempt a navigation because.
Can you hear me?
Yes.
I got something I can tell.
Okay, one moment, please.
Okay, dokie.
Let's see a cone. Are you using the ultrasonic sensor?
Yes, that's the ultrasonics, and this is the homebrewed ultrasonic sensor. One of the things we did with it at the Ross discussion group was limited to 1.4 meters, and it navigates much better that way. All right, Tim Lewis, you are on.
Well, I just discovered something interesting. Gunnar Holt just bought Advanced Animation, so the 2 companies now merged into one. Advanced Animation is another company on the East Coast that does similar things to Gunnar Holt. Gunnar Holt just bought it. So they're going to have two facilities now, one here, one where they don't.
Okay, who is this? What?
Gunnar Holt Productions just announced on their website and their thing that they just acquired the company Advanced Animation, which does animatronic stuff similar to their stuff, but they're on the East Coast.
Mm-hmm.
So now the 2 companies, apparently, I'll find more out from Garner when I talk to them in person, but from what I can see on the internet, they basically now one company, and they'll run one here, one there. So he just expanded his company by a lot.
Yeah, if you got a link, put it in the chat there, Tim. Okay.
All right, I will.
All right. Hey, Stephen, what do you got going on there?
Oh, well, I've been working on a project to do facial tracking and facial recognition, and I'm using a brand new camera called the Husky Lens 2. This is made by DF Robot. And basically, I mounted it on a pan and tilt mount that has a skull on it. His name's Tony. And he's Tony, the talking head. He's the talking head. Basically, this brand new camera from DF Robot is pretty cool.
Well, the other day at the Builders SIG, you had him singing "I Ain't Got No Body," right?
Yes, I did.
That was awesome.
That's good.
Computer, tell me about the Brew Robotics Club.
The Homebrew Robotics Club is an innovative community project aiming to democratize robotics development. They're building a marketplace for robotics data and software. using AI to streamline programming, and developing an affordable robot with custom hardware. Inspired by the 1970s Homebrew Computer Club, it empowers hobbyists and encourages open source collaboration in robotics.
Okay, stop.
Tony's awesome.
Yeah, it also it's tracking me too as I move. It'll pan.
Tokyo Mahariba.
So it's following me. And basically the camera talks to this Arduino Mega, sends data, the X center, Y center of the video image. And when it moves whatever to the left, it tells it to turn to the left to keep the X center in the middle of the screen. So it does that back and forth. That's for the pan. It'll also do tilt, but I got that turned off right now because
is that using OpenCV?
No, it's all in this camera.
Okay.
It's a DF robot camera sends these signals through serial data or I2C to an Arduino or a Raspberry Pi or whatever you got that can receive serial data.
Yeah, but it's all built into the camera, right?
It is. There's 22 different algorithms built into this new one. It does facial recognition. It does pattern recognition, colors, QR codes.
Oh, is that the Husky Lens too?
Yes, it is.
Yeah, Husky Lens too.
I was given this by DF Robot at the Maker Faire that we just did in Treasure Island. They gave it to me for free because I had one of their other cameras on Beer 2D2 and I was driving it around and talking about it because I talk to everybody.
Yeah, they're pretty good about that.
Yeah. So they gave me I was one of 3 people in the world that actually was given one of these in the United States. And I couldn't say anything about it for almost 2 months. But I'm saying something about it now, okay?
You probably sold 3 or 4 of them right here.
Yeah, they're only $70. It's pretty darn cool.
There you go. They're hitting them with the pie. All right. Who else has a show and tell this evening? We got to get going.
Yeah, I also have a DF robot one. It's smaller. I can share my. Oh, I guess I am sharing my screen. I just have it mounted on a front of the humanoid. I just have like a little cover for it right here. So then, and it also does everything within the camera. So it does the face tracking. So on the white humanoid, I have it following the faces if it sees you, but it also does the gestures like thumbs up or okay or some of the other ones. And it has the light display here.
Which one?
What?
Are you using the same camera?
No, it's a smaller version.
It's the earlier version.
Is that the Husky Lens one? This one?
Yeah.
I don't recall the name, but because someone mentioned that it was on the mailing list and that it was on sale. So like I just picked up 3 of them because it was before the Maker Faire.
Oh, I think you're talking about the gesture recognizer from DF Robot.
Yes, and with the face detection.
Yeah, I've got that in my cart right now. That's the Gravity Offline Edge AI Gesture and Face Detector. 5 gestures, 10 faces, right?
Yeah, something like that.
That's kind of a menacing looking end move you've got there, Dee Dee.
Oh, because I
kind of has a Terminator look to it, doesn't he?
Because I'm doing some repairs for the robot block party, so the face is off right now, but basically this is the face.
Oh, okay, that's the new rubber face. Okay, nice.
Yeah. I wish it was. Oh, it was so
that's
hard.
Not creepy at all.
I had to 3D print the mold and then pour it into the mold, and it was like, oh my gosh.
We have arrived in the uncanny valley.
Yeah. So okay.
All right, that's awesome. Thank you very much.
This new camera will also, you can hold your hand up to it, and it can see all your fingers and all the joints in your fingers, and it has data for every position. So you can do all kinds of hand gestures with this one also. That's
Interesting.
another build. It's got, like I said, 22 algorithms of different things it does.
Did you have the earlier one, or this the first Husky lens?
No, I've had the other one too. No.
It's a lot. It's a lot. It's a lot of improvement. Then it sounds
All
like.
right, we need to get to our presentation, people.
Okay, whatever.
It was just answering a question.
That's
I
fine.
know
Go ahead.
it's much more
Go ahead and answer
capable
the
than the
question. Go ahead and answer
original
the
version.
question.
Yes, much
Hey,
more
Camp, I got a
capable.
10-second video.
No, we need to get to the presentation because we've already been an hour. We're going to show and tell. Tom, I meant to say, Stephen, I didn't mean to cut you off. You want to finish up what you were saying?
It's much more capable than the original version. It even has audio. It has like you can do a webcam with it. It's crazy what it does. If just go to their website at dfrobot.com and they talk about it. There's several pages. It's good stuff.
They're out of stock.
They're supposed to get some more. I ordered some things through them just the other day. So
cool.
All right, Nathan, are you ready?
You have a table to put things on.
Let's get this presentation rolling. It's a nice G1 in the background there. Hey, Tony.
Zoom here.
computer, what time is it?
It's 7 p.m.
Oh, you want closer? Oh, yeah. Here's good. Okay.
Nathan, I've seen you do some live streaming lately.
Yep, I've been starting to try to do that.
Very good.
Discoverable. We're gonna delete in orbit. Trying to unbrick my demo here. I decided to try to put it on the in-orbit Wi-Fi, and it was faster, but nothing could see each other.
You gotta love a live demo.
Yep. Yeah, it's fine. It's not too difficult to change back. Need to go back to the robot. Calypso. Connect. Go. See if this works again. Hopefully it works again. Uh-oh. Dude. Just a second. So manipulator.
I'm glad somebody let you in.
There we go. Sage.
Hello, James Bond.
I should be able to do attach. Okay.
There's the LeKiwi.
Yep.
LeKiwi with manipulator.
Hold on. Let's do Hotspot activate. Connecting. Okay, I think I unbricked it here.
It's about $500 for the whole thing, it looks like.
Yep.
For a 5-volter. Looks like a fun assembly.
It's not too bad. I'll disconnect. Why can't I see my phone?
And some 3D printing.
So there we go.
Good documentation, isn't it? Pretty good.
Meh.
Or is it okay? Just okay.
Only okay. Only.
All right. Well, that's better than half.
There we go. Okay, I unbroke it. There we go. Cool. It's back. Okay.
Nathan Lewis, ladies and gentlemen.
Okay, I still gotta get on the Zoom here.
And
Zoom. Where we go?
the
Launching
LeKiwi
meeting.
low-cost mobile manipulator.
Manipulator.
Nathan has Rossified.
Rossifying it. Yes. All right. Turn off my camera here. No video, no audio. Join. Make sure I've selected the right photo album. There we go. Meeting is being recorded. All right.
Hey,
Perfect.
yeah.
Yes.
Got one more thing I can show. It'd be cool. It's going to be cool. Okay.
Okay. Hang on. Did you share your screen or what?
I'm on. Yeah, hold on.
I have to share screen at some point, but I can wait as long as possible. I
Well,
think
he's
you
about
want
to do the
nice
presentation now. You ready? Are you ready to go, Nathan?
As soon as you're ready. Here, yeah. I won't complain about a few more minutes. Okay. LeKiwi mobile manipulator, Sig Robotics. There we go. Let me undark mode this. Settings, light mode. Near. All right. Plugging face. Before I get into the live demo, I might as well use the in-orbit network to do most of the casting here. Does it come back? Does it come back? Did I lose my Zoom? Yeah, I lost. No, Zoom reconnect, please. There it goes. Okay, cool. It's unstable. Yeah, no. Okay. There we go. Be some assembly pictures here. Try to just finagle all of the photos. Did I start building this? Hold on. Arm. Okay. Here we go. Cast my screen. Share. Use system desktop capture, content only, laptop screen. All right, can you see my screen?
Yes.
Yes.
All righty. So, okay, I'm ready whenever y'all are.
We're ready.
All right. So, guess I'm the presenter for this month. All right. So, I am too tall. Yeah, okay. All right. All right. So today I'm giving a presentation, or actually, sorry. So, hey, I'm Nathan. I've been a member of the club off and on over the years. Generally done robotics since I was a kid, and before people start thinking I'm going to go into life story, the comment was mainly about I think the major thing that has, at least to me, the most interesting thing that has changed since I got into robotics years ago, and now is probably, besides things getting faster and cheaper, it's probably the advent of 3D printing, at-home 3D printing. It's definitely been a significant like trend or a significant thing that has affected what you can do as a hobbyist. And so in the last couple, especially now that 3D printers are like super cheap, you can go to Micro Center and get a relatively serviceable one for $200, $300. So with the recent resurgence or in interest in robotics with this whole AI thing that hopefully that I'm pretty sure you can't have missed, there has been, especially this year, there has been a lot of interest in like open robotic or sort of like open robotics platforms, especially the whole like reinforcement visual learning model type stuff where mimicking actions of basically giving the robot its own information about the state the robot's in, information about what a person is doing, and then just all of the video of what's happening, and then training things. So this robot comes, so this robot on the table here, I looked it up from the camera, is called a LeKiwi mobile manipulator, or it is a low cost, or it is the LeKiwi low cost mobile manipulator. So it is
Nathan, can you unshare your screen and show us that robot on Zoom?
Okay, sure. Stop share. So here we go. This is what it looks like. So we've got 3D printed robot arm, 3D printed, basically every structural component in here except for the screws is 3D printed. And well, the servos and the screws. So, all right, so I share my screen again. Share system desktop capture laptop. All right, so about this time last year, a group called the Robot Studio released this 3D printable robotic arm that they called the SO-Arm 100 or the standard open arm. There was a small revision of it that came out about 3 or 4 months later that makes some of the parts a little easier to print, but still not like super easy. But and then a couple months after that, a group at University of Illinois or at Urbana-Champaign did this 3-wheel omni-wheel chassis. And I was wondering I know we were discussing what is the name of the robot, like why is it called the LeKiwi? Turns out I had no idea a 3-wheel omni-wheel chassis is called a Kiwi drive. I did not know that before. So you got the 4-wheel with the 45-degree rollers as mechanism. These are called, besides in the class of holonomic drive chassis, these are called Kiwi drives, or the tricycle drive thing. So I guess Steve Dillo was the one who introduced this to me a couple months back. I think it was either the May or the June meeting. He had one that was assembled, but the framework that this is intended to be used with is from a group called Hugging Face, and they have this framework called LeRobot. And there's been a couple, I've seen people in the club have discussed, also I've seen people discuss online. Also, I have tried to commit code to it. It's not the most stable thing in the universe. It's a little fragile, and it's also pretty, well, I mean, everything's opinionated.
That's a bit of an understatement.
A bit of an understatement. Okay, so I don't want to like rag on code that I didn't like look at too closely. So yeah, but it is a little fragile, and it's very much intended to do okay. So here's the model, the robot that we want you to use. Don't make any changes to it. Run the code and cross your fingers. So there has been, so at least within the club, there was interest to use this thing with robot operating system. And considering it's been around for about a year, I figured somebody on the internet must have written a ROS package for it. And the answer to that is I couldn't find one. So I might as well make one, right? Full disclaimer, I don't have the entire thing working yet, but I do have the chassis working. The arm is I'm still trying to put together the URDF for the arm. Because there's a lot of joints, and the one in the reference, the one that comes along with the 3D models for the arm doesn't cover this version of the arm, it covers the old version of it. So I'm trying to make one for the new version of the arm. But that aside, so wanted to talk about, at least first, like the hardware that's in here. So it 3D printed, all of the parts again are 3D printed, but it's not the easiest print to do. Like if you have a really low-end printer, it might be a bit difficult, because while the arm, or I mean the chassis itself is fairly straightforward to print, and no complex geometry, just a couple of plates, a couple of fasteners. But the arm has a lot of curves on it. So if your printer has trouble with bed adhesion, or if you're using a filament that like has a tendency to warp, it's terrible time. So I used a carbon fiber reinforced PETG because it's still pretty cheap. It's not the nylon, so it's only $25 a roll at Micro Center. But so it helped with the warping, and also I do have a fairly high or a reasonably high end printer. I have one of the mid-range bamboo printers. So I did actually I have a couple of videos that I put together, or not put together, a couple of videos I took out of my printer's time-lapse camera. And here we go. So in terms of actually printing these things, I think this one is, yes, the arm part. So there are a bunch of curves again, so it can be, oh boy, that's chunky. So it was relatively straightforward. So there's one file that you could, they have a combined STL file that includes all of the parts for the arm in a single print. So if you have a pretty standard like 25 centimeter by 25, the 256 by 256 millimeter printer, you can print in one go, at least for the components of the arm. And so we got this one. And in order to try to do some of the curves or make it better, I used the multi-material feature on my printer, which my printer can swap filaments at runtime. So what you can do is you can print, since the main parts, PETG and PLA do not stick together. If you try to mix them, it makes a really broken like plastic. It's very crumbly. So what you can do is you can basically print the incompatible type of plastic between the support and the actual part. It means you have a solid interface surface and it prints very nice and smooth, and then you can just peel them apart when it comes off the printer. So highly recommend, I don't have looping on this, but highly recommend doing multi-material prints. It makes printing these a lot easier. So then there's other parts. You can see some of the filament swaps. Basically, the blue stuff is PLA, the green is the actual stuff I printed it out of. But so we got that part. That's the wrist, and then here's the base. Or it goes by really fast, but printing the base. Some people might say don't print bases with, but either way. Fairly straightforward on that. It took me probably about a week to get the arm to print correctly, and it only took like a day to print the rest of the chassis. Chassis is really just a couple of plates, there's a little bit of adapter brackets. There are these, so out of the box, they want you to use the Vex Omni wheels, but which are not expensive. They're really reasonable price, only like $15 a wheel. So if I recommend using them, but if you really want an adventure, Steve Dillow again found a 3D model of an Omni wheel, and I decided that I wanted to try printing it. So I printed my own Omni wheels for this. So there's a single carrier piece that goes in the center, and then you have to cut out basically 1.5 millimeter metal rod to hold all the little rollers on. The little rollers are printed out of TPU, or printed out of a foaming TPU, so they have some grip. I think that's in here somewhere. There's a new base for the arm that has a flat bottom. Let's see. Yeah, so there's printing the wheels.
The one thing that I would add about printing versus the Vex wheels is that I'm following the like the Hugging Face and Pollen Discord, and it seems like the Vex wheels are out of stock everywhere, so everybody's just printing them now.
Oh, okay.
I've seen like just in the past week I've seen like 3 different LeKiwis, and they're all printing the wheels, and they're all using TPU for the rollers.
Okay, that's what I did too.
I'm going to take credit for that.
Yeah. So if you want to, so Steve's got he put up a model or a 3D model for basically the model, or what am I trying to say? Right, the 3D model that you sent to the list. You needed to print an adapter bracket in order to go from the mounting mechanism that the 3D model used to the type of servo that the LeKiwi uses. I just modified the model and embedded the motor mount directly into the wheel, because like if I'm 3D printing this thing anyway, I might as well just change the wheel model and get it as one part.
Yeah. I will admit to having been under time pressure for a hackathon that weekend.
I
And so
wasn't growing.
it was just easy.
Yeah, no worries. I did also post the model that I made to the list. I also scaled it up so that the default size is the expected size that you would want for the robot. So with that, yeah, since I mentioned it, so the servos that are all in here are the Wave Share serial bus servos, specifically a servo model called the ST3215. It is, for lack of a better description, a Dynamixel knockoff. They're not as good as the Dynamixels. They're more fragile than the Dynamixels, but they are really cheap. I managed to, even though they're metal geared, they have enough torque where they can blow up their internal gears before they'll break the arm pieces. I had one of the arm joints bind up, and I self-destructed one of the servos. And I probably should flip this on my shirt. So I've got that. There were some other parts in here, right? So electronics wise, this one is using a Raspberry Pi, or the base Kiwi anyway is it's a Raspberry Pi. They recommend using it's this board called the WaveShare Bus Servo. Basically, it's a USB to serial converter with the power pins for the servo motors. And then I just did my own, there's just a lithium battery, or 3-cell lithium RC battery, a 5-volt regulator to drive the 5-volt logic on the board, mainly the Raspberry Pi, and a camera that I have on the front. And then there's just the power to the servo, so it's fairly
What
straight.
kind of camera is that?
So I just a PiCam 3 on two different cameras. So there's a PiCam 3 wide angle on the gripper on a basically on a gripper on the arm. On the arm there is a PiCam 3, and then on the base there is a ArduCam time of flight depth camera.
You can see that better if you weren't sharing your screen.
Yeah.
Camp, you can just click the meeting tab and you can see there's tabs in my Zoom. I can see both. User done.
So either way, not super important. So I guess the starting point here was at least to Rossify it was I kind of set out with the goal of not writing any code if I didn't have to, like, not that I don't want to, but just to see what was on the internet. And so I did actually find so the starting point anyway, I did actually find somebody has put together a ROS2 control plugin for these serial bus servos. So ROS2 control wave servo hardware interface. So this will let you bring in the servos into ROS2 control, so you can actually manipulate them, and you can just write a config file. So I guess I'll start by, so my workspace here that I put together, this is I'm working on a package called, what happened to the projector? Okay, whatever. So I'm working on a package. I'll post a link to GitHub on the mailing list, but it's just called LeKiwi description, and it basically just there'll also be a sample workspace. The workspace only contains 2 packages right now. That it's that WaveShare thing, and then this LeKiwi description, so we don't have to look at it too much. But so the first thing to start off with was defining a URDF for this chassis. So I had not written one of these before, so this was a new experience for me. So I split it into a couple of different components. I split it into a omni-wheel base. I split it into the ROS2 control configuration, and then it's not in here yet because it's not done yet. There'll be the arm, and you'll be able to turn on the arm if you want to. And I might just put the arm in a different package because some people have put together simulation models of this arm, and all of them have to use real hardware on them. So I might see if I can pull any off-the-shelf stuff. But the idea is that if everything's pulled into ROS2 control, you should be able to use out of the box the ROS2 controllers, and you should be able to use things like Move It without having to do anything special. So the first thing to start off with is basically this omni-wheel base. And so I started in here. So right now there's just a couple of links. So kind of the convention that I used for defining the transform geometry of the robot is each plate is, so since there's this 2-plate structure in the robot, there's basically a link on each plate, So base link is the bottom plate, and then there's just upper plate, which is below that, and then all of the wheels are referenced off of base link. And or basically, sorry, there's a base plate, there's the transform that I'll eventually be assigning the model for the motor mounts on. I don't have them quite set up yet because I was trying to figure out the rotation, because I'm trying to use the 3D print models for the meshes in the RViz display and for Gazebo, which has been working mostly pretty well so far, other than the orientation is a little funky, because you care about the coordinate frame when you're 3D printing something is just as long as it's got the axis correct. Like, you don't really care where it's zeroed, it'll just figure out how to stick it on the bed. But like, yeah, so the plates are the origin is in the center of the plate, on the motor mounts is in some random corner. So we still working through that. So we've got this base link, and it just pulls in meshes, or some of the 3D print the meshes, base plate, defined all of the parameters on its size. So, the plate is, 216 millimeters across, or, 108 millimeters in radius. It's, 7 millimeters thick, 30 millimeters. The wheels are 30 millimeters above the base and such. So we have our base plate, we have our upper plate. There is some joints, and then some linkages, and then probably the fun one was using macros to define the wheels. So there's this exacro, or I guess that's how we say it, exacro macro, that defines a wheel. It takes the angle you want it off the robot, and then it does all of the fun math to calculate where that wheel should actually be, and then adds the visual model from the print, which is just called the wheel carrier. I don't have the little rollers yet because there's 18 of them per wheel, so 50 something in the whole robot. But so we got wheel carrier, and then there's a collision mesh. So we can just use simple cylinders for the wheels and the base plates. So I have the collision mesh set up for the wheels. There's completely incorrect inertial properties because I need to take it back apart and weigh everything. And then there's a joint specified for the wheel. And so what we can start with, in order to kind of in order to verify that the URDF was actually working, let me switch to, so I'm going to drop for just a second because I'm going to switch to the Wi-Fi network. The robot's on. I hope this works. See if I come back. Well, okay, I've connected to my phone, but will I reconnect to Zoom? Let's see. Waiting on reconnection.
So I see you're using Move It. How does that work with, like, I always think of that in terms of just plain stationary arms. How does that work with a mobile robot?
I think it mostly works by translating the coordinate frame. So you have to, if you're trying to figure out where the object is in front of you, you have to basically translate between the frame that the arm is in that Move It is expecting, and you have to know the translation from the arm to your chassis. So if you find a thing that you want to interact with, your software needs to translate that into the arm's coordinate frame, and then you can tell Move It to grab it. Correct. So that's kind of the idea. What I'm going to do is, one of the other things too with the arm is, because it's only a 5 degree of freedom arm and not a 6, there are certain types of manipulation it can't do. So the idea is going to be, if there's a direction it would like to move the arm in but can't, I will translate the robot that way to recenter things. Since it's an omnidirectional chassis, you can drive in any direction, or in 2D space anyway. So, okay, it looks like I'm back. So what we're going to do is log into the robot here, and hope that works. There we go. It did work. Okay, so we're going to attach to our thing here. So the first thing that we're going to do is just the display the URDF, just to show that can work. So we've got this display URDF thing, which it just runs a robot state publisher, not a joint state publisher. So then in another tab, we can source ROS, go to our workspace, source the workspace, and we can run there should be, I wrote a little little thing. Yeah, publish zero joints did the publishes, unassigned states, and then we can then run rviz and hopefully see the robot. And so now we have our nice little it's hard to see. Well, I can't see if you can see the details of either.
We're seeing
so
your URDF.
Yeah, so we have the actual 3D print models, and I tried to color match it. But we have, our plates that represent the frames. We have our lower one, our upper one, and we have the wheels. And we can also see that the collision meshes are correct. When we turn on the collision meshes, they're actually overlapped on everything. You see the little holes disappear on the plates, and then the wheels turn into solid cylinders. So I have my collision aligned. And now to actually show something interesting happening, we can leave rviz up, and then in tmux here, we can kill that stuff. And then we can run LeKiwi description. We can run our hardware control launch file, which then brings up, or actually, I'm getting very ahead of myself. I'm just excited. So, right, so we have that on the wheelbase. The URDF pulled everything together. Then we have this ROS2 control definition. This was one of the big ones. So in here, we go through and we say all of our joints that we are basically our hardware plugin, which is Waveshare servos. You can have multiple hardware plugins if you have multiple types of hardware that you want to talk to. Says what serial port to connect to. I need to set up a UDEV rule so it's something regular. Talks at 1 megabaud. Then you basically define for each joint what ID servo on the bus is. It basically the wheels on the base are 7, 8, and 9, and then the 6 servos in the arm are 1 through 6. But they're not mapped yet. I have them unplugged so I don't destroy the arm on accident. And then, so yeah, we basically our left wheel, the front is the axis pointed directly forward along the arm. So we have our left wheel is this one, our right wheel is this one, and then there's the rear wheel, which is under the LiDAR on the back. And for each of them, we basically can control the position, the velocity, the torque output of the motor, because the servos, they have current sensors on the drive motor. So you can specify a current limit to limit the torque, or measuring the current, you can measure the torque being applied. Then you can also measure the motor temperature so you don't overheat them. There's 3 of these, 1 for each wheel. And then in our config, before we get into the configuration thing. So this was our launch file. So basically it just brings up our robot state publisher, which reads the hardware, the controller manager, which brings up the robot description thing, and ignore the OmniWheel drive for just this second. And so now that we have our thing started up, or our robot state publisher and our OmniWheel controller, we're now in rviz. We now actually have real-time feedback from the robots. So though I can't move the motors when they're once it's powered on. Well, I can try to move them, but it resists. But you can actually see the wheels moving. So if I try to grab one and turn it, you can see the wheels actually flexing in rviz, which is reading the encoder off of the wheels. And so with that being said, we can then.
Hey.
Yep.
Question. Just wondering, like, if for your all that setup, did you have any kind of base that you were using or reference? Like, a lot of us use the Lino Robot 2
No,
hardware.
I did not.
Or did you start from scratch?
I started from scratch. I looked at the so in terms of reference material, I looked at the Waveshare servo repository includes an example of each of the type of joints that you can represent. So in terms of actually setting up the URDF, I just read the docs, or I was reading through the docs. I looked at the sample. It seemed straightforward because it's just transformed core. It's a list of frames and transforms from each frame to the next. The hardest part was figuring out which axis was which, and then trying to figure out the order of the operations were applied in. So, because it's technically, you give it a rotation, it rotates and then translates. But the thing is that it actually tries to convert the translation coordinates from the host space into the target space. So the interface you have to it is actually looks like it is a transform and then rotation, but the software is actually rotation then transform, but the URDF system is doing the coordinate conversion from you, and that had me mess. Anyway, once I figured that out, and so also liberal use of transform spaces instead of trying to like compute all the signs and things.
Do we understand that you did holographic transforms from scratch?
Holonomic. I didn't write the holonomic controller from scratch. I'm getting to that.
Oh, go ahead. Sorry.
Sorry,
I was just asking.
I was starting to get ahead of myself. So let's see, where am I at? I just wanted to cover, so at this point, I just wanted to cover the ROS2 control, mapping joints in the URDF. The joints that exist are just the wheel rotations. Also, the transforms so the ROS convention is that the positive X should face out of the front of the robot, and then all wheels and joints should rotate around the positive Y, or wheels should rotate around the positive Y axis. X should point in the direction that turning the wheel in a counterclockwise direction will make it go that way. So the x-axis should point in the direction that the robot will go if the wheel moves in a positive rotation angle. And so that means it rotates about the y-axis in the URDF. So, all right. So with that said, ROS has in ROS2 control as part of that. So just the hardware interface is one level. The next level is, okay, well, now that we have this hardware interface, what kind of controllers can we use to drive things? And so ROS2 control has a fairly healthy set of controllers that can be used for things. Let me just pull up the GitHub to that. So it has, if I go to the right directory, oh, hold on. I'm too deep in here. Hold on. ROS2 controllers. All right. So the big ones that we are interested in is, so we have our classic Ackerman steering. We got our bicycle controller. We got differential drive controller. There's a mechanism drive controller in here already. And the one that we're using is the OmniWheel drive controller. Which you can give a config file in your DOS package, and that is this config omni controllers. And so we basically have this list of so under this OmniWheel drive controller, we can basically say what wheels are on the robot. And the cool thing about this is it actually is generic. So you can have the wackiest set of wheel arrangements that you possibly want on your robot, and it will figure out how to make it go in, hopefully it will try to make it go in the direction that you want it to go. So basically, you tell it what wheels there are. You tell it what the size. It does assume that all the wheels are the same size. So you give it basically the radius and how far away they are from the center. Then you give it how offset the first wheel is from the coordinate frame, which that magic number right there is actually pi divided by 3. So it's just rotating pi divided by 3 to the left or counterclockwise. You tell it, so that's just the offset to the beginning. And then the first one, you tell it what offsets the wheels are at relative to the center of the frame. We can say that we want a velocity interface because we really don't care about position control on the wheels. We can give it limits on the velocity and then publishing rate. So realistically, all we're doing here is we're just describing to the OmniWheel controller, there are these wheels, they are this large, they are placed in these locations. And then when you start that up, so if we go back to here, you can see that, after we activated this is the launch file that I wrote. This is back to that hardware control launch file. So the last bit in here was the Omni drive controller, and that is then started. You can see it comes up, it then consumes the wheel joint interfaces, and then will map command velocity to the frame. And so let me start. So I have my gamepad here. So don't have any autonomous stuff working on here yet, but I do have teleop working. So this is a controller. It is connected to Bluetooth to my laptop. And the robot.
Can you stop sharing your screen so we can see the robot?
I will do that. Yeah, I just need to get the joystick controller started. So this is the joystick. So we're going to run the joystick node. Oop, something happened. Hold on. I did something wrong. Sorry. FG. Okay, cool. Sorry. So we're going to run our joystick node. It eats the controller. And then we're going to run our teleop twist controller, which I configured to basically map the left stick to the linear motion, the right stick is the rotation. There's just a bunch of args to remap command velocity to the omnidirectional drive, and then let me stop sharing my screen. Stop. And if we can pin, I'm going to put it on the floor because I might drive it off the table. But
You
if
can do
we just
Floorbot
want
challenge.
is the Floorbot.
You might do a phase. You might try to do a phase 4, huh?
I don't want to do a phase 4. So yeah.
Think about the phase 4 is it still needs to run when you put it back on the table.
Maybe we turn the lights back on. All right. Alrighty, so we now have our joystick here. So the left stick controls the linear motion, and let me just turn it around upside down because this is the camera's view of this whole thing. And now it stopped working. It moved ever so briefly. No, there's not. I was having trouble getting it to actually work. So hold on. What happened? Technical difficulties. It moved for a brief second, and then my laptop might have switched Wi-Fi networks.
You got video?
Hold on. No, it worked. Don't worry.
Or it didn't happen.
Okay, now that's still up. That's still up. Okay, hold on. Maybe this is the whole. What is happening here? Hold on. Hold on. All right, running that. Running the OmniDrive controller. Why did it stop moving? Maybe I had an issue. Hold on. What is my teleop thing doing? Joystick node. Mapping to command velocity. That stopped. Why? Why did that stop?
Are you running this off your phone network?
I am running this off of my phone. Oh, hold on. Well, maybe this is my phone. Nope, that's not doing anything anymore. Okay. Ow. Okay. That's why the projector looked weird. I kicked it. Okay.
Settle down there, Nathan.
Hold on. Hold on. So we got this.
No pressure.
Okay, yeah. Right, so that started up. Let me actually just look at the, maybe I can't see the ROS 2 topic list. Clicked point. Omni wheel drive.
You got 6 minutes, Nathan.
Omni wheel drive controller. Command velocity. No, echo. I'm trying to see if the actual data is coming over here. Okay, I'm seeing messages come over, but the controller is not sending data. Time stamps. Okay, that's actually somewhat of a positive sign. So I see the messages, it's just nothing's happening. Okay, hold on. So then we're going to just disconnect my controller.
Do you have a battery in your joystick?
Yeah, the light was still on, so hold on. It just seems to have.
Always be suspicious of power.
Always be suspicious of power. All right, so the joystick reconnected. All right. So we should see the joystick node. We should also see projects, Docker run. Should also see ROS2 topic list. Okay, we see all that stuff. We see the joystick, ROS2 topic, echo, joy. Okay, I see that happening. Okay. Just copy the command out of my notes. Do that. Which was it?
There's an issue if you're using stamped versus.
There we go. There we go. So we can rotate. We can then drive about in any direction.
Oh, you've gotten farther than I have. But of course, I haven't really had a whole lot of time to mess with mine recently.
Very nice.
Very nice.
Yeah. We're doing floor bot here. Can't pick anything up, but we can get
the mobile manipulator.
The other, right? Yeah.
If you don't use ROS, you're using whatever they did. They did some other framework.
Yeah, it's called theirs is called LeRobot.
That's LeRobot.
All right.
That's awesome, Nathan. That's great. I know a lot of work went into that.
Yes.
You were sweating it on the demo. Right on time, though.
Right on time, though. All right. Not yet, because I finished it at lunch today. So it wasn't moving before I got here, actually. Today. So yeah, so that's what I got. Anybody have any questions online or in person or whatever?
Does this work in Gazebo yet?
I haven't tried. That was the next step. Was to get Gazebo up. I just didn't have time in the last couple of weeks to get it working. But that is on my list of things to do.
Nathan, that's really, really awesome. Are you sharing anything on GitHub for any of your
They just
code
asked.
or
Yeah,
anything?
I'm going to post the repo when I get home tonight.
Thank you.
I will send out a link to the mailing list.
Excellent demo, Nathan. Does anybody else have a question they want to ask Nathan? Is there anything else for this evening's meeting?
So the arm is rated to pick up 500 grams, or so is basically a pound is the official limit of what the arm can grab. Skinny Coke can. So one of those little 8-ounce ones.
Jim, you guys are having a contest where you're like trying to fetch a Coke can or something, aren't you?
At RSSC, yes.
All right.
We're going to be, and I think it's February though, so we have a few months.
I got a
Nathan,
Christmas
you get
project
that?
to do.
What's it got to do?
Yeah, I got that.
Coke
I got that. February. Drag a Coke can
HBRC.
across CSU Long Beach's rooms. Okay.
This will be HBRC versus the Southern California Robotics Society.
Oh yeah.
Game on.
Yeah, game on. You've been served.
Thank you very much, Nathan. That's awesome.
All right. Thank you.
And Nathan's our program chair for next year also. So, hey, listen, programs is everybody's job, okay? It's not just Stephen, Nathan, and me. So if you know of somebody that would be a good presenter, ask if they're interested in doing that and get the information to Nathan, and we can book them for a presentation next year.
Well, I tried to get Automatic Addison, and he agreed, and then he canceled on me last year, so earlier this year. But
We'll have to try to get him. We'll have to try to get him on the HBRC.
Yeah, you guys should try, because then it's not me pestering him. You know, a different fate. And he doesn't know I'm a member of this club. Maybe, I don't know.
Maybe he does. All right. Is there anything else this evening? Tim, did you have a quick show and tell?
Yeah, I got a quick show and tell.
Go for it.
I need to screen. I need to share the screen though.
Go for it.
Oh, what is that?
Tim, you're muted.
I think I saw Steve say you wanted one of these books. I will be holding it for him.
Thank you.
Tim, you're muted.
I'm muted. Oh. Okay, everybody hear me okay?
Yes.
Yep.
Okay, one of the things I've been keeping track on is the Electro, the Westinghouse robot from the 1939 World's Fair. It was in a museum in Mansfield, Ohio, but 2 or 3 months ago, the guy that ran the museum passed away. And so the original owners of the Electro robot have been fighting back and forth with the courts or whatever to get it. And they finally got it. Let's see, does my marker show up on this thing?
Yes.
Yeah.
This is his head. This is his body. This is John Weeks. This is I forget what the
Wow.
I forget the other guy's name, but they finally got it back in their possession. And
What about the dog?
the dog's nowhere to be found, unfortunately.
Fascinating. Wow, that's a historical piece there.
And they're getting ready to. You can see they're getting ready to move it,
Mm-hmm.
put it out,
Wow.
taking it out.
Does it function at all?
Well, that's what I'm going to show you here in a second. That's what it looks like
Still,
when it's put together.
is it still smoking?
That part, this head doesn't have that mechanism inside of it. So
That was classic.
The
yeah.
non-smoking version.
I guess I don't know.
Smoking transistors is hazardous to my
That's
health.
what it looks like. Let's see now.
That's a different head from what I've seen in other pictures.
Well, that's the head that they had. Apparently, there's another head out that it's got the mechanism, but they don't know where it is. Now, these are the sons of Jack Weeks, and his father had helped make electro, and during World War II was in his basement. So he temporarily loaned it to the Mansfield Museum, and this guy is such an asshole. He just clowned onto it, wouldn't let anybody touch
Watch
it.
your language.
He's
All
such,
right.
such a bad person.
There we go.
Wouldn't let anybody do
All
that.
right.
He finally got
Thank
the
you
right.
very-
He finally got the rights back. Let me stop my screen settings. I need to see if I can switch to a different area here. Okay. See, where is it?
I'm going to go ahead and close this meeting out, Tim.
All right. Well, I have videos of it actually moving, so I don't want to.
That's okay. You can go ahead.
I'm just not sure how to get to it. They're on my.
That's fine. We need to close out the meeting because you got people there at Maker Nexus, or not Maker Nexus, but in orbit that
All
are
right,
ready
let
to
me see,
split
let me
and
see if I
stuff.
can
So
share from this screen. All right. Here's.
Yay.
That's from what, 1945, right, Tim?
1920, 1929 World's Fair.
Yeah.
29. Wow. That
29.
thing's almost 100 years old.
yeah, that was a famous World's Fair.
Yeah, he is. He is. Let me
Wow.
just close this one down.
When did you take this video?
Oh.
Wow.
I need to get Rocky to do that. And
Tony
Simone.
can do that. Tony can do that.
That's such a piece of history.
Oh, the
That's
arm.
Pretty smooth.
Never mind the man behind the curtain.
Yeah.
So what is it? All relays and switches and
motors and switches and relays.
wow.
So they have a
Wow.
they have a plan for preserving it.
Yes. It's going to another museum, and that's the other guy that you saw in the picture. He's just cracking up because he got the whole thing working. That's the little movements I originally saw it when it was at the Pacific Ocean Park, except the mouth was talking too. So that's
Wow.
all that.
Oh, the mouth moves.
Hasn't moved since that point in time.
It had very rudimentary voice recognition, didn't it?
I'm sorry, what?
It had very rudimentary voice recognition, and it
It
took
did.
a record, didn't it? A
It did.
regular
It did. It
vinyl
did.
record.
It did. So it's going to another museum there in Mansfield. They're working on it. I'm in contact with the people that worked on it, and let me stop sharing there. I mean, in touch with the people that are working on it, so I'm going to see what I can do to do it, and I'm going to see if I can recreate Sparko. It doesn't happen. It doesn't. Robot doesn't exist anymore.
Yeah.
Parker's the dog, right?
That's the dog.
Yeah.
All right.
It's not
Very
very
fine.
not very complex. It's a motorized walking frame, basically.
Yeah.
All right.
This
All
is like on the level. This is like on the level of the mock-up of the Boeing 2707 SST.
Well, what I like to do, Jim, is what you've done with Orange. I like to get that working with them so that I can actually talk to it and they can see them.
Yeah.
I'm
All
trying
right.
to find. I'm trying
we
to
need
find.
we need to close this meeting down.
Oh, you're
Okay.
working.
All
I want
right.
to thank you. I want to thank everybody for coming to the meeting and participating. I want to thank the new officers for volunteering and signing up. Like I say, we'll have a sometimes annual holiday junk exchange on December the 17th. We'll have to figure out where that is. And unless there's anything else, I'm going to make a motion the meeting be adjourned. Do I have a second?
Really quick. Robot block party in Mountain View at Circuit Launch off Fairchild Drive this weekend on Saturday.
Post to the mailing list.
Okay.
Is there any more?
I'll keep you guys informed on how this.
I already posted it to the mailing list.
Are there any more meetings this month?
No. The next meeting will be, it'll be a physical meeting in December. It's not virtual. Then we always do the Ross meetings on the week. We do the Ross meetings on Tuesdays and the AI meetings on Thursdays. Follow the mailing list, okay?
Our AI meeting, AI SIG,
Okay.
7 o'clock.
All right. All in favor, meeting be adjourned, say aye. Aye.
Aye.
Those opposed, say nay.
Nay.
Ayes have it, meeting adjourned.